Hello everyone, hope you're excited. Get your notebooks out and ready to go. I said notebooks. Have your iPads ready and here we go. We're going to talk about area of equilateral triangles and regular hexagons presented by Mr. Cote and Mr. Leadforth. Okay, so just a quick introduction to the shapes. You probably want to draw these out. But the first shape up here in the upper left hand corner, this shape is what we call the equilateral triangle. Equilateral triangle, if you remember, has 3 equal sides and 3 equal angles. Should be saying congruent, I guess. That's an equilateral triangle. The other figure that we're going to talk about today is over here in the upper right hand corner, and that is our regular hexagon. Now the regular hexagon has 1, 2, 3, 4, 5, 6 congruent sides, and the interior angles 1, 2, 3, 4, 5, 6 congruent interior angles as well. But the way we're going to talk about it, if I can just focus your attention down here in the lower right hand corner, right there, we would like for you to think of a regular hexagon as just being 6 equilateral triangles. That way we'll only have one formula to memorize. Well, speaking of those formulas, here they are. So the first shape is our equilateral triangle. The formula for the area of an equilateral triangle is you take any side, we'll call it S, square that side, multiply it by the square root of 3, and divide by 4. Now that probably sounds crazy. You're like, what about 1/2 base times height? But just be patient. We're doing that on a coming slide. S, it's important to know that S stands for side. So I will highlight this. This is an S, not a 5, and that is the side of the equilateral triangle. So S, S, S. Okay, that was a bad color choice, but S, S, and S. And so those are sides of the equilateral triangle. Now, when we come over here to the right-hand side and try the regular hexagon, I can take anything. Basically, I want to find the area of maybe this blue one. So again, I'm using the same formula, side squared root 3 over 4. And then what I'm going to do is, since there's a red, orange, yellow, green, blue, purple one, I'm going to just take that formula and multiply by 6. And that will be the formula you use for the area of a regular hexagon. So why is that? Holy cow! Why is that? Well, you're probably looking at this slide and just freaking out. Because there's all kinds of information. But basically what we did here was we drew an equilateral triangle. And so we have that. We have a side, and another side. Alright? And what we did was we dropped a perpendicular right through the middle. We dropped an altitude, which in an equilateral triangle would split this in half. So side divided by 2, side divided by 2. Not only does it perpendicular bisect it, but it also bisects the angle up here to make them both 30 degrees. And so the rule we're kind of using here is if the side across from the 90 is something, the side across from the 30 is half as much. So I should probably get those fancy arrows out. That was pretty cool. The side across, okay, maybe not. The side across from the 90, there you go. Side across from the 90 is S. The side across from the, maybe I should make them smaller. I don't know how to do that, but so the side across from the 30 is S over 2. Let's see if I can get them out of here. And then the side across from the 60, as you look across there, is going to be that whatever the side across from the 30 was times the square root of 3. So this is a messy picture, but basically when you simplify it, you're coming up with a triangle that has an altitude there, that's side over 2 root 3, a base of S, and we have other information as well. But I'm going to take you back just to the old area of a triangle. So that's this right here. If we take that and just look at the area as 1/2 base times height, that's our old formula from the other day. The area is 1/2, okay? The base, what's the base? The base is this thing. So if that's the base is just S, okay? And what's the height? Well, this height we said was S over 2 root 3. and so that's going to go here. So the 1/2 from our old formula, the base is the base of the triangle S, and the height, we did a little bit of work to decide over 2√3. And so if you take S times S, you get S squared. There's a couple 2's in the denominator. When you multiply them, you get 4, and the √3 is there as well. So it's side squared √3 over 4. Now, I don't want to have to do all this work. I mean, the side itself just looks crazy. The slide itself looks crazy. So let's just go ahead and use this formula and just kind of bypass this derivation from now on. So what I would want to do is just go ahead and use this formula right here. So how about a regular hexagon? Why does that formula work? Well, the one we're using basically says that if you have an area of side squared √3 over 4 that we just derived on the last page, basically you have 1, 2, 3, 4, 5, 6 of them, and so we're going to take that formula and multiply by 6. Remember this thing right here, that is an S, which stands for side. It is the side of the equilateral triangle, which also is the side of the regular hexagon as well. Alright, I had that inscribed in a circle just for fun. So we'd like to just do some straightforward problems. You might want to sketch this down. It's basically an equilateral triangle with side 10. I want you to find the area. Well, okay, the area is equal to side. I'm not following my own rules. Let me go back for a second. Okay, it's not going to let me go back. There it is. Alright. The area in general is side squared √3 over 4. And then when I fill it in, it's 10 squared √3 over 4. And so the area is equal to, what is that, 100 over 4, 25 √3. And that's in square units. Alright? So that's a quick, straightforward problem. Our second problem here is a regular hexagon. Again, we just want to find the area. So what I'm basically going to do here in my answer, which will be in white pen again, I want to find the area of one little equilateral triangle, and then I know that I have 6 equal ones in there. So it is 10 squared √3. Oh no, I didn't follow my own rules again. Let me erase that out there. Basically, what I'm going to be doing when I'm finding the area is I'm going to do side squared √3 over 4, and then I have 6 of those when I'm done. So I feel like I did this a minute ago. I had like a 10 in there. I got 25 √3, and then now I have 6 of those. And the key here is only the number out in front gets multiplied by 6 based on old rules. What is that, 150 √3? And that's in square units as well. Alright? So here we have a more complicated problem, and I'm just going to write that, what was it, 150 √3 that we got for a regular hexagon with side 10, so I don't have to do that work again. Basically, we have this big hexagon that we already know the area to, and what I did was something fancy in here. I just put an equilateral triangle inside. Alright, and so I want to know, what's left over. What is the stuff here, and here, and here. And so you want to say, like, oh, it's 150 √3, but that doesn't make sense, because you want to subtract out that area on the inside. So let's subtract out side squared √3 over 4. That side is, in our problem, 12. And so that's, 144 √3 over 4. What is that? 144, so 72 over 2, maybe 36, maybe it's 36 √3. So if I erase all of this, it ends up being 36 √3. And so you have 150 √3 for all of this, okay? And then you take this middle part and subtract it out. So we got 150 √3 minus 36, so what is that? 4 gets us up to 40, 14, maybe 114. I think it's 114 root 3. And that would be in square units as well. Alright? And so that finishes that one off. Okay, that probably came at you pretty fast, and we're going to do some practice in a minute, but just a quick summary here. On this first problem right here, we have an equilateral triangle with 3 equal sides and 3 equal angles. The area of that is side squared root 3 over 4. S stands for the side, so try to highlight it a few times, but this is not a 5, it is an S. It's for any side of our equilateral triangle. Now, when you come down here to look at the regular hexagon, then what you want to do is just basically find one of those, and then once you find one of those, you plug it in here. Side squared root 3 over 4. That's a equilateral triangle, and you have 1, 2, 3, 4, 5, 6 of them. You just can't see them, but I can draw them in if you want me to. And then you're actually going to be multiplying by 6 there to get your answer. And so those are 2 formulas, and hopefully they made some sense to you. Alright, well, now we're going to have some time for questions. I don't know if you guys have any or not, but we also have some questions for you guys. Enjoy the problems we have for you. Goodbye.